Okay, so open to section 9.4. We're moving on with compound interest type equations into annuities. Annuities and then amortizations, things like paying off car loans or mortgage loans, what these next two sections are going to focus on. So a few definitions. Annuity is a sequence of payments made at equal times, and typically of equal amounts. An IRA, if you're familiar, a individual retirement account is one of the most common ones. An ordinary annuity is one we'll be typically focusing on, where a payment is made at the end of a compounding period. So much like compound interest, annuities use compounding to generate interest and to generate the money that they do. Future value is, again, the amount that's left over after a time period has run through, after all the interest has been made, all the payments have been collected. And a sinking fund is a term for finding an annuity, finding the amount of money you would need to invest at a regular time in an annuity to make a certain amount. So, for example, if you wanted to use an IRA to save for retirement and you wanted to have, let's say, $40,000 by the time you were 60, a sinking fund would allow you to calculate how much you need to deposit on a regular basis, say every month, every few weeks, so that given a certain interest rate, so that you'll have it in that same amount of time. So let's look at a few examples. The best way is, as I said, just to look at some examples to see what we are talking about. Now, if you look at these two equations I've given you, one thing to keep in mind is that I'm never going to make you memorize these equations. They're long and very complex. It's not your job to memorize these. What's more important is that you can understand them, recognize them, and know when to use them. Now, you notice, if you have your book or you have it open online, on page 425 is the formula for the future value of an ordinary annuity. Now, they've broken down to one general term. I have broken down to two specific equations. They're the same equation. Mine is a little more deliberately laid out. There are two basic types of annuities when we talk about compounding. One that compounds annually, as you see on the equation on the left, and one that compounds n times per year. So very much like a compound interest account that you would save with. And this is our breakdown. P is the deposits made at the end of each year or end of each compounding period, since we are using ordinary. R is the rates, T is the years, and N is the number of times compounded per year for these equations. So when you're finding an annuity, finding future value, that's what A represents in each of these equations, the future value of an annuity. You just put in the appropriate numbers. For example, you deposit $800 in an IRA every year for 30 years. If the IRA earns 4.3%, how much is in the account after 30 years? This is a typical question. So we're finding future value. That's the term for what we're looking at here. So what I would say of you is, and remember on test or quiz, I provide you, especially on test, I provide you with this kind of equation. And then I provide a formula sheet, or I would provide a sheet online through Blackboard and say, use this for the formulas. Go up here and we say which of these two equations we would need to use. And since it's compounded annually, and this one says compounded every year, we'll use the one on the left. And here is that example. Let me zoom in a little bit better. So I put in my principal, 800, that's deposited at the end of every year. My rate, 4.3%, now is a decimal, 0.043 to the 30th power. And then it's just a matter of doing the math. Make sure you follow order of operations. you do 1.043 to the 30th first, then subtract 1, then multiply by 800, and then lastly divide by 0.043 to get approximately $47,183.97. And that would be the future value of this account. So another typical question. You deposit $500 in an IRA every 4 months. If the account earns 7% and is compounded every 4 months, after 25 years, how much is in the account? So again, a future value equation. If the account earns 7% compounded every 4 months, so N is the number of times compounded per year. So if it's compounded every 4 months, how many times per year is that? That's what our N is going to be in this equation. So looking at our answer here, I'm using my second equation. P is my 500. N is 3 since it's compounded every 4 months, so that's 3 times a year. And then it's a matter of just doing the math. You end up with about $99,430. And of course, since this is we're talking about money, make sure you answer it appropriately, meaning that you put a dollar sign and you run to 2 decimal places. Lastly, this is the opposite. Now we want to find out how long it would take to get to a certain level. Now this is the sinking fund, as was talked about earlier. And this is a separate equation that you can use. And again, this one will be provided. This is the second equation, format I should say, that you can use to find, if you want to say, for example, if you want to save $100,000 in so many years, using this will allow you to determine how much you need to deposit in a particular account at a regular basis. So for example, you want $75,000 in retirement in 30 years, how much do you need to deposit monthly in an IRA earning 3.5% compounded monthly? So looking here, I have this. So using that same formula, I put in what I want to reach at, what number I want to reach. That's 75,000. My rate, 3.5% is 0.035. Compounded monthly, so the N is 12. And I want 30 years. So my T is 30. Then again, from here, it's a matter of just multiplying and simplifying by order of operations. And it comes out to be that at that rate, for 30 years, you need to deposit $118 every month. So this concludes section 9.4. Again, the focus is annuities. As always, if you have any questions, feel free to contact me, and have a good day.